Hello guys, welcome back. In this today's lecture, we'll see how to design the 4-bit binary parallel adder circuit, right? So if you want to understand this 4-bit binary parallel adder operation, right? So first thing we need to understand what is the difference between the serial operation as well as the parallel operation. So then only you will be able to understand, right? So how we require these many full adders, why we cannot able to perform the addition operation by using the single full adder, why here we have considered the 4 full adders in order to design the 4-bit binary parallel adder operation. So first we will try to understand what is the meaning of serial operation as well as the parallel operation. So then we will go to design the how to design the 4-bit binary parallel adder circuit, right? So if you see that, for example, let me consider some a bit value for explanation, b bit value, something I am going to write a3, a2, a1, a0. So one more is the b3, b2, b1, b0. It means that some binary number I am going to consider, right? Here also I am going to consider some binary number. Now what we are going to do here is exactly right. We have two ways to perform this operation. One is by using of the serial addition, another one is by using of the parallel addition. Now what is the meaning of serial addition means, for example, if the above example, if you are going to perform using the serial operation, now what will be happen means we will be having the only single full adder, right? So single full adder means how many inputs we have? A, B, right? Outputs are the one is the sum, then another one is the carry. So this carry will be storing in some memory elements that will be given again as the input value. Now see that what is happening means, first if you want to add, at a time we cannot able to add the 4-bit numbers. 4-bit numbers means 1-bit number, 1-bit number, 1-bit number, 1-bit number. You cannot able to perform the at a time 4-bit addition operation. For that, first what we used to do means we need to perform the addition for the this 1 with 0, right? So we are going to perform the addition for 1 0. What is the a value now? 1. What is the b value now? 0. What is the sum value? After 1 plus 0 means we will be getting the sum value equal to 1, carry value will be 0, that will be stored in the memory element. Again for the next time you will be getting this carry value, right? Now what will be happen once this operation is completed? By using the same full adder, I am going to add the next time 0 1. I am going to find out the sum value as well as the carry value. After some period of the time, I am getting the adding the 0 1, so that I am going to get the add the 0 1, again I am get the sum value, carry value. After some time 1 0, again we are getting the sum value as carry value. It means that one full adder we are using the multiple times, right? So why one full adder is sufficient here means, in case of the serial operation at a time we are not getting the 4 outputs. First we are getting the output for this one, then after some time this one, after some time this one, after some time this one, right? So it means that one full adder we can able to use the multiple bit addition operation, because one after another. It means that so addition operation will be performed in terms of the one after another. At a time you are not giving all 4 bits, right, to be perform the addition operation, right? Now see that if you consider this one, this is a slower operation. Why it is slower operation means, right? So first we are getting output for this one, after some time this one, after some time this one, after some time this one, right? So for example, it is taking 1 second, for next 2 seconds second output, 3 seconds, 4 seconds. So finally we are getting the output at the 4th second, something like this. Now is there any possibility that the moment if I pass the input value, can I able to get the output value directly or not, right? So this is what we called as the parallel operation. Parallel means at a time we need to pass the input value. What is this input value? 1 0 0 1 0 1 1 0. The moment I pass this 4 bit, a bit value 4 bits, b bit value 4 bits, the same time I need to get the output value, right? In case of serial operation, what is happening? First we are getting output for this one, after some time this one, after some time, after some time, something like this, right? Now my requirement is something is like, the moment if I get the output for this one, the same time I need to get the output for the all bit. It means at the duration of time t1 itself, I need to get the output for the all the 4 sums. This is my requirement. Now if you observe, if you take the simple full adder, single full adder, what will be happen? So here if you remember, then one more important point. So it is full adder means, right? So you cannot able to pass all value 1 0 0 1 in the single terminal, 0 1 1 0 in the single terminal. At a time only we can able to pass the one input value only. Now if you want to get the all outputs at a time means, right, so we require the multiple full adders instead of the single full adder. Now how many bits addition we are trying to perform? 1 bit, 2 bit, 3 bit, 4 bit. So how many full adders are required? I required the 4 full adders, right? So 1, 2, 3, one more is the 4 full adders, right? So it means that what is the A value, B value, right? So this I am going to write in terms of the variable A2, A1, A0. This is I am going to write in terms of the B3, B2, B1, B0. What is that value? 1, 0, 0, 1, 0, 1, 1, 0, right? So for this we need to find out the sum as well as the carry, right? So how many full adders are required? 4 bit means 4 full adder. If something question is something like this, right? So design 3 bit parallel adder means 1, 0, 1, 0, 1, 0. How many full adders are required? 1 bit, 2 bit, 3 bit means 3 full adders are the required. So in my case, by default in examination point of view, they will be asking design 4 bit binary parallel adder, right? So design 4 bit binary parallel. So how many? 4 bit means we require the 4 full adder, right? So parallel means at a time, right? So at a time we are going to perform the addition for the all n bit information. This is the one thing difference between serial to parallel. Now question is that we need to design the parallel operation. Then one more difference is it is the slower operation, right? Why it is slower operation means first this one, after some time this one, after some time this one, after some time this one. But in this case at a time, right, at a time we are giving the input, the same time we are getting the output values, right? So it is the faster, right? So always remember that parallel means at a time, serial means one after another. So to perform the parallel operation we require the multiple full adders, right? So let it be from LSB, this is the first full adder 1, full adder 2, then full adder 3, one more is the full adder 4, right? Now what is the input we need to give? First one LSB, right? 1, 0, right? So this is in terms of the binary representation. If you want to write in terms of the variable, you can write something this one as the A0, B0. Second addition is 0, 1, right? So 0, 1 means we can write in terms of the variable means A1, B1. For that third bit addition means we can write the A2, B2. Fourth bit addition means we can write the A3, B3, right? So the moment you add the 1 plus 0, what is the expected output? Sum is the expected output, right? So what is the one more expected output? Carry 1, right? So right, so 1 plus 0, what is the value? Let it be, we'll consider 1, 1. So 1, 1, what is the value? 0. Now what is the carry value? Right, so carry value equal to 1, right? So next bit value is nothing but the A1, B1. So what is required here along with this A1, B1? Along with this value, what is required here? Carry also required, right? But where this carry is generating? At the first full adder, right? So this carry should be added to here, right? So again you will be getting the sum 1, the carry will be added to here. You will be getting the sum 2, the carry will be added to here. You will be getting the sum 3. Finally you will be having the carry which is final out. So if you understand how this operation will be performed means, you take any number something like this, right? So 0, 1, 1, 1, right? So what is the value? 1, 1 means 0 carry. It means that the first full adder produce the sum equal to 0, carry equal to 1. This carry should be added to the second full adder. It means that it will be added with the second full adder. Along with the carry we have the inputs A1, B1. Now what is the triple 1 means? 1, 1. Now what is the sum is produced? 1. What is the carry is produced? 1. The carry should be added to the next level, right? So like this we need to find out the output by using the 4-bit parallel adder, right? So see that here there's a diagram. Initially we don't require the carry because by default you can consider the half adder also. This is correct only because by default initial bit we don't have any carry, right? So it means carry equal to 0, or here for if you consider half adder also it will work out. For remaining things we need to consider the full adders only. If you have the confusion, just to consider this also full adder only. This is not mandatory for the first full adder because by default there is no carry will be generated in the LSB bit operation, right? Suppose in some cases they might be asking design 5-bit binary parallel adder. Now try to answer how many full adders are required. In case of 5-bit binary parallel adder means how many full adders are required? 5-bit means something like this, right? This should be added with the another 5 bits, right? So how many full adders are required? Good, 5 full adders are the required. Suppose if I want to implement this 5-bit addition operation, right? So then in case of the serial operation, how many full adders are required? 5 full adders or single full adder? we required only single full adder. Why single full adder means at a time we are not going to perform the addition operation, one after another we are going to perform the addition operation. It means that the same full adder can be used for the multiple times, right? So conclusion is that serial operation means one after another, parallel means at a time. So parallel operation is much faster than serial. Why means here we are implementing the circuit design by using of the multiple full adder, where in case of the serial adder we will be having the only single full adder to perform the multi-bit addition, right? Thank you very much.